Thank you for joining us at Cribble today for our next webinar in our series on observability best practices. We are very excited to share more information with you about our latest product release, LogStream 2.2, which is now available for download at cribble.io/download. We will highlight the major improvements and updates in this release, and then deep dive on data collection, which will include a live demo. During the webinar, we encourage you to ask questions using the Q&A button at the bottom of the console. We'll have time at the end of the presentation to answer your questions. Participants will be muted throughout the call, so we do encourage you to use the chat feature and the Q&A feature. We'll be recording today's webinar and we'll send a link to the recording when it becomes available. So please check the email account that you used to register. For information on upcoming events, please check cribble.io/events. Clint Sharp is the CEO and co-founder of Cribble and will be our speaker today. Clint, I'll now turn the presentation over to you.
Thanks, Brian. All right, super excited to be here today to talk about our latest release, LogStream 2.2. This is, we'll say it later. It's a really big deal. We are adding for the first time, we believe, batch processing capabilities into the log ecosystem, and we think this enables a ton of new use cases as well as being able to manage the volumes of data that exist in 2020 in a cost-effective way. So let's just get started. To start with, let's talk a little bit about kind of where we've been from a LogStream perspective. The product was first released 1.0 in October of 2018. That gave us, the core user experience that you see in the product today, debuted in 1.0. We iterated very quickly to add support for things like Elasticsearch and other inputs and outputs. 1.3 added our data preview and encryption capabilities. Preview is obviously core to the user experience if you've used our product, and you'll see it in the demo later. And debuted super early, just a few months after initial release. We sprinted again to go add support for the universal forwarder, Splunk universal forwarder, to support byte streams and syslog type of protocols. And what you see, kind of rapid innovation throughout the 1X branch in terms of getting the core user experience right for a single node, and expanding out to the number of protocols that we needed to support in order to implement a true observability pipeline for our customers. 1.6 then added support for metrics, because again, in the observability world, it's not just logs, it's also metrics. And we added support for StatsD and Graphite and other metrics protocols in that release. 2.0 was a huge release for us last October. That added our distributed management capabilities. We have a with petabyte scale. So single management console scales to massive data volumes. And then 2.2 adds support for data collection, which we'll be talking about, along with a number of management improvements. So to talk a little bit more about kind of 2.2 specifically, we're going to focus a lot on data collection during this webinar, but we've added a ton of functionality into 2.2, some of which I'll be demoing after the presentation content. So to start with ad-hoc data collection, this is what we're going to be talking about. In 2.2, we have ad-hoc data collection. This is a user can come in and run a job to suck a bunch of data back in and replay to the destination. We'll be talking about that in detail. Release 2.3, which will be out in a few months, will add scheduled data collection. So that'll be the ability to collect from APIs. So if it seems like we're missing that, we're not. It's coming. We just wanted to release the minimally viable feature set so that people could start getting advantage of that feature set today. Also in 2.2, improved troubleshooting, live tail of captures, centralized log search for our internal logs, time range filtering, etc. We've added support for reverting commits through the UI. That was a very popular end user request. Hey, I can make a commit, how do I revert? In 2.1 and before, it was, go to the command line, run a git revert. We've now added that support inside of the user experience. Custom pre-processing scripts allow us to run your code before it comes into the engine. And so that would enable us to support potentially even custom binary wire protocols and other types of formats that we may not have anticipated on a TCP port or in a batch input, like our collection technology. So lots of expansible capabilities out in the field with our custom pre-processing scripts. Another popular user request was adding support for Splunk's HTTP event collector raw endpoint. We've supported the structured event endpoints for maybe since the beginning for a very long time. We've added support for their raw input, which is a slightly different format where you basically put the metadata in the query string and you put the just raw bytes into the payload. So that's supported now. Oh, I mentioned this a little bit earlier. We've also added a number of internal logging management improvements. You can now redact potential fields inside of our own internal logs, and you can get very fine-grained about our logs at what level they are, for various different components inside of the distributed system. We've added support for new destinations, including syslog UDP, another popular user request. We'd recommend you use TCP, but if you're in a place where you need to output syslog UDP, you can do that now, and also added support for our partners at Min.io. Numerous UI and UX updates, which I'll demo later on, around sources and destinations, pipeline page designs, just a nice refresh across the whole of the experience to make it easier to understand and consume. We've also made it much easier for you to send us diagnostic information. So if you are having a problem, hopefully you never have a problem with the product, but if you're needing support, it's now a single button, easy upload of diagnostic information to us. And then plus, please go check the release notes. There's a number of other improvements and changes in the 2.2 release. All right, so let's talk a little bit about log management as it exists today. So in the world of Splunk and Elasticsearch, there are other people who are talking about index lists today, but the vast majority of people are doing log search on top of an index that allows them to do very, very fast needle in a haystack searching. And there's a number of different use cases for logging tools as they exist in the world today. The first, and as they were originally invented, was for troubleshooting. And so this was a huge sea change in the mid-2000s that, hey, I want to be able to, from a centralized experience, be able to search logs coming from potentially dozens of systems so I can troubleshoot real-time production issues. For that use case, recent data is incredibly critical. If I'm troubleshooting a production outage and I only have access to 10-minute ago data or an hour ago data, then every time I make a change, I may have to wait that amount of time before I can see whether my change actually fixed the problem. If I'm doing troubleshooting and real-time investigations, I also need super fast response times, because if I have a new question, then I need to be able to get the answer back to that relatively quickly. And so log search systems were built fundamentally to go after this use case. Stream the data from the endpoint in near real time, give very fast needle in a haystack search performance, and they're very much fit for the purpose of that particular use case. But over time, logging tools have also been put into service for a number of other use cases. For example, analytics, large-scale web analytics types of questions. I plow all of my HTTP access logs or all of my clickstream data into a log system, and allows for read-time aggregation. So that means I can change what questions I want to ask after the data is already landed. I can say, hey, since I had the full fidelity raw data, I can arbitrarily ask any question of that particular data. But the value of each individual event is pretty low. It's relatively rare for clickstream type of data that people go searching for one particular log event. It's not really root cause analysis as much as batch processing and large analytics types of questions. And then also they're used heavily for security investigations. So that means high fidelity data. If I'm doing a breach investigation, I may need to go back a long period of time. The breach may happen months or years after the fact. That data needs to be online. Like, I need to be able to get at it. That's why we tend to put it into something like a logging tool. But I'm not as concerned about the speed of the query, because if the breach happened months ago, I can afford, I don't need sub-second response times. I don't even need second response times. I can run queries that may take minutes or potentially an hour or two to go complete. And so since we've combined all three of these use cases into one particular technology, the index for the second two use cases is pretty wasteful. In the analytics use case, I'm just doing a table scan anyway. And in security investigation, it's nice to have faster queries, But if it ends up costing me more, I would probably trade off having a cheaper, much, much cheaper way of storing this data but still making it accessible. And so in today's world, like, I just don't really get a choice. If I want to be able to query my data, if I want to be able to analyze my data, I have to put it all into an index in order to get this user experience. And index data is expensive. So if you look at how this works in traditional logging systems, you have your full original raw data that gets compressed via gzip or LZ4 or some sort of known compression mechanism. And rule of thumb is you're going to get about 10-to-1 compression. So if you have a byte of raw data, you're going to end up with a tenth of, or if you have a gigabyte of raw data, you're going to have 100 megabytes of compressed data. But then we need to index it. So in order to give you fast needle in a haystack search performance, we need to have this index that allows us to find the right records amongst this data set and point you very quickly into the place where you're looking. So the index is actually about 3 times generally the size of the raw data. Now it's highly variable, depends on the cardinality of your data and the actual contents of your data. But rule of thumb is that if you're indexing the data, whatever the size of the original data was, on a single system, you're going to end up at about 40 to 50% of the size of the original raw data. Now, most of logging systems need the data online in fast storage, sitting right next to them in order to query this data. So then, in order to make sure that they don't lose data if there was a failure of one of these particular processing nodes, and remember that these were designed originally for on-prem, so the idea of kind of durable cloud storage, didn't really exist when they were originally designed. They need to replicate the data. So when you're finished in a traditional logging system, you're storing 1.2 bytes of data for every 1 byte of raw data. It's 120% of what's coming in. So if you're bringing in a terabyte a day, you're storing 1.2 terabytes of data on disk. And this needs to be in very fast, expensive disk. So S3 infrequent access for log storage is 1/10 of the price of block storage, and that is on Amazon's price sheet today. So if I wanted to store a terabyte of compressed raw data in S3 infrequent access, that would cost me about $12 a month. Now, to put that same compressed raw data, not even indexed, just that same compressed raw data in block storage is going to cost me $100. When I index the data, that's going to cost me $400 a month. And then when I put it into a log search system, then that's going to end up costing me $1,200 a month. So truly, putting data into a inverted index is the right thing to do for the right use cases, but it's going to cost you 100 times more than putting the data into inexpensive block storage. And so we think the ability to plow large amounts of data into cheap storage is fundamentally a game changer for this business. And on top of that, over the last 10 years, the amount of data in the world has grown by nearly 50 times. And that's not stopping. By 2025, it will grow another 2.5 times. It is a 31% compound annual growth rate in data. Every year, it's going to grow by another 30%. Meanwhile, you say, okay, well, hey, storage costs are coming down, right? But not nearly that fast. So we've seen a 5.4x decrease in storage costs. Storage has definitely gotten cheaper. But over that same time period, the amount of data has grown by 50 times. So we're finding ourselves, and anecdotally, when, back in my Splunk days, I remember reference customers for Splunk being big in 2012 when I first joined the company at 10 to 15 terabytes a day. Those were big customers. And now everybody is doing 10 to 15 terabytes a day, or has 10 to 15 terabytes a day that they wish they could be onboarding. So something has to change. We can't keep using the same data management techniques that worked in 2010 and expect them to work till 2025. We really need to start thinking differently about new approaches for how we can manage this data. And so thusly critical LogStream 2.2. So 2.2 adds support for data collection and replay. And so we've always given you the ability to easily route data to multiple destinations and to lay that data down into cheap storage. But in the world as it exists today, no real solution has made it easy to get value out of the data that you're putting into cheap storage until now. LogStream 2.2 adds ad hoc data collection with an easy, intuitive user experience to go searching or go run a job to suck in the data that's going to be relevant. So what this enables us to do is to collect all of the data that we think may be interesting, and decide later whether that's valuable. We can just spool that data somewhere cheap, and if we don't know whether we're going to end up needing it, then for literally a penny on the dollar, we can keep that data, and if we end up needing it later, then we still have it. And this enables a massive reduction in infrastructure costs, especially if you start to look at all those use cases that you were using for logging and you start to split apart, hey, like if I'm just keeping it for a potential investigation later, or hey, if I am really what I'm doing is bulk analytics, then we can put the full fidelity data somewhere cheap, and we can put a subset of that data into the analysis system where that really matters. And so LogStream 2.2 brings batch processing to the log world. We think there's a lot of use cases for batch processing that we haven't even really explored in full depth. Cost control is a big one. The ability to easily move data between systems is another. 2.2 offers an intuitive interface that I'll be demoing here in a minute for allowing any user to come in and replay data from cheap storage. That's any IT professional, any security professional, anybody who can use a simple user interface to go run these jobs can. And so that's hugely liberating, because now this can become self-service. So your users don't have to go write Python or write some big batch job that's going to suck the data out. They can simply run these jobs to suck the data in. 2.2, this is elastically scalable in the same way LogStream has always been elastically scalable. So especially for batch jobs, we can easily scale up compute to make the job run faster. It's a parallel processing problem. More compute, the job will go faster. You can process the data the same way you've always processed data in Cribble LogStream. So you can run it through routes and pipelines. You can parse it, you can enrich it, you can structure it, you can aggregate it, you can do whatever you want, and you can deliver that to any of our supported destinations. So a couple of use cases. So this allows you to decide, is this data that I want to analyze now? I can convert logs to metrics, put them into a time series database. I can take logs potentially that I don't know whether they're interesting and put it into cheap storage for archival. And some of this data I can just throw away altogether. And the benefit that I get from this is that we can massively reduce the amount of data that we're putting into our log tool. We can retain data for a much shorter period of time, because instead of trying to make the log tool also the big archive, we can now retain that data in cheap storage instead. We can replay this data for investigations later, or for batch analysis. So let's say that I had done some aggregation of the data in the pipeline and sent it off to my time series database. And because those aggregations, I'm asking them as they're streaming by. Let's say I had a different question that I wanted to ask. I can stream the data back through and replay all that data and re-aggregate it with different aggregations and send that data to my time series database. And lastly, we can also easily load ephemeral log systems. So one of the most exciting approaches to this is, if you don't know whether this data is going to be interesting, if I need to do an investigation for some time period, go suck all the data out of my archive, bring it back to the front of the stream, deliver it to a system that stood up expressly for the purpose of doing this investigation. And that, for the first time, really enables these types of use cases. So now we'll transition to a demo. Give me 1 second to swap my screen around. Okay, here we are. So we are in Cribble LogStream 2.2. I want to highlight a couple of minor things that have changed about the interface. Sources, destinations, and collectors are now under this menu under data. Right now, I am in a worker group. So I have multiple worker groups in my demo environment. I'm in the log worker group where I have my collectors defined. Same interface that we've had for a long time. I'm here looking at my routes. What I'm going to do first is we're going to go look at the new data collection feature. So under collectors, I have just one collector defined. This collector is an S3 collector type. We support also collecting data from a file system. So it's not just S3 that we support. We also support any file system. So if you can bring an NFS mount to that has, again, much more affordable storage, we can use that. We can also run collector scripts. So you can actually bring your own code. Any type of custom script that you may want to run can be called to feed data back into our collectors. This auto populate from box here allows us, if you already have an S3 output defined, we can pre-populate all these collector settings from your existing output configurations. In this case, I'm collecting from the data collection demo bucket. This path here is a very important concept. So path here is defining our partitioning structure. And so what we want to be able to do is to easily rule out large portions of the data set so that we're not reading a bunch of files which are not interesting for our particular job. And so this partitioning structure has these bash-like variable syntax that defines, hey, this directory is the year, this directory is the month, this directory is the day, this directory is the source type, this directory is the zone, the IP. And so any of these fields that you see in this partitioning expression, I can put into my filter expression for the collection job, and we will narrow down the data set to only those directories that match that particular portion of the partitioning expression. So super powerful, somewhat of a complex concept, but very common in big data and data management. We already support these partitioning expressions on the output, so you may have seen that or run through our S3 or the affordable log storage in S3 class, where we talk a little bit more about these partitioning expressions. So if you want to learn more, would highly recommend you check out our sandbox there for affordable log storage. Defining an API key and secret, we're using MinIO in our demo environment here. If we're in AWS, you can easily use IAM credentials. You do not need to populate these. Recursive says that we want the job to go look through the entirety of the data set and recurse every directory. Down here, there's a few more notable settings. So we've got this set event breakers here. So we are telling it that we are expecting new line delimited JSON data. And that's how Cribble lays the data down by default. We can use all of our standard event breaker rules. So you could have, maybe you have just raw stack trace logs. We can build event breakers for that. It's really, event breakers are a super powerful way to take arbitrary streams of text data, extract timestamps, and figure out where that is. This has been used for the Splunk Universal Supporter support since version 1.5 or so. And this is now available actually for all of our TCP inputs and our S3 inputs, and event breakers are super powerful facility. The default here is fine for me. Here we can also run a custom command as a preprocessor, as I mentioned earlier. I can also add arbitrary fields and metadata. Here we've already added one called collection, and the value is demo collector. We now have the ability to add this metadata all across the product. So if you see them in sources and destinations, you can now add arbitrary metadata. And in my example, I'm going to go ahead and send this to routes. But if I was doing just a one-off collection job, if I select this to no, I can choose which processing pipeline I may want and which destination that I want it to route to. I don't, and I don't want a conditioning pipeline, so I'm going to go clear this off. So this job's already configured. What I want to do now is I want to run this job. So I'm going to go over here and click on run. And this populates our configuration dialog for what we want to do when we run this job. The mode, right now I have set to preview. The time ranges can be filtered, again, by that partitioning expression that we defined earlier, so I can get super prescriptive about the time ranges that I want to look at. Filter true just means match everything. And so what I'm going to do right now is I'm going to run a preview job and show you just how easy it is to go explore this data set. So as I hit run, this is going to dispatch a job, and it's going to bring me back the first 100 events that it finds into my preview window. You can see it's already done here. I now have 100 events that are available to me. We have this data is Palo Alto Networks firewall log data. You can see it's generated in CSV. We had parsed that before we ended up writing it to S3, so we actually have already this rich structure in the JSON that we had written to S3, and we have all these field names which are available to us that can be used for whatever analytical purposes that we have. So one of the things that I want to do is I want to go run a job let's say that I'm doing an investigation just on one particular IP address. So what I'm going to do is I'm going to run, I'm going to add a filter expression just for this particular source IP. And we're going to go validate that works. So let's do that. And then this will also factor into, we'll see how this affects the performance of these particular jobs. So I'm going to hit source IP. Now I'm going to run a preview job again, and I'm going to validate that, okay, indeed, that it is only matching this one particular source IP. So the filter expression is actually working. Next, what we'll show you kind of what the other modes are available. So discovery is, hey, I want to run the full job, but I don't want to actually output it anywhere. I just want to see how big this data set is, how many files it's going to match. And so if I go run this discovery job, I'm going to run it for everything, and we're going to go see how big this data set is. This data set is actually kind of large. So if I go look over here in my inspector, we're showing you real-time statistics about what's happening with these particular jobs. As I expand this, I can see the progress of how many tasks are being scheduled, how long this has been running, the results. You can see right now we have 3,000 approximate files. I don't actually have enough time to show you the full job in this particular case. I ran one earlier today just to see how long this was going to end up taking. And looks like I ended up canceling it before. Oh, no, that was a preview job. Looks like I ended up canceling it before, or the other job expired. So this is going to take a little while. I think there's actually about 50,000 files in this data set. And so I'm a little impatient. So I want to run a slightly faster job. I'm going to go back here to run. And this time I'm going to do the same thing I did before, which is I'm going to say, hey, I want source IP equal to this particular IP address. Whoops, I did preview instead of discovery. Let me back up. Let's run again. I'm going to run a discovery job. I'm going to say source IP for this IP address. Now, as I hit run, we will see actually in the inspector that this goes significantly faster. So this is going to rule out all the data set that is not relevant that does not match that particular IP address. And we can see when we're looking at the file names here, we're only matching file names with that particular IP address. And I don't know how many are here, but this job here that where I'm running, oh, it's already finished, right? So you can see my other job over here running against the full data set, obviously still running, still scanning files. How many do we have here? We're already up to 25,000. This only matched approximately 3,000 files. So you can see how it's easy to really rule out, large sections of the data set and get very prescriptive about the performance of that particular job. So lastly, I'm going to go ahead and run this full job, and it's going to bring all the data in that I want. And again, I'm going to run it just for this particular source IP. And as I hit run, we're going to go back into the inspector. And here inside of this full run, we can see the progress of what we're running. We show you the files that are being run. You can see in real time kind of what the statistics and of what's coming in. And I can also do things like, hey, I want to look at a live tail here. And so I can see the data that's flowing through right as that's flowing through. And again, matching to that one particular IP address. So super intuitive, very easy to come in and run these jobs. Anybody should be able to come in here. We'll show you real-time statistics graphically of how much data is moving through while the job is running, and approximate progress as the data is proceeding. And so this should be accessible to any persona inside of your organization and make it really easy to go explore that archive, bring the data back, make it easy to deliver the data where you would like. So that's data collection. I want to show off a few more features. I already showed you the live tail, but I'll show it to you in a slightly different way. So as we look in monitoring, if I'm looking at a particular source, let's say that I go look at my Splunk Universal Forwarder source. Now in distributed mode, we can show you a few different things. We can show you live status of each individual endpoint. So if you have a number of different workers, we can show you the status of each worker, and before you had to navigate to the worker node to get this type of information. I can also show you live data as the data is flowing through. So as new events come in, I don't know how many are coming in. There we go. We're getting a live result of what's coming through the pipeline. So all around troubleshootability, understanding of what's happening in the environment, we want to make a centralized experience that's easy for anybody to come in and easily troubleshoot what's going on. In the same way, if you're asking for help from us, we now have a easy to use diagnostic bundle uploading service. So here, if you put it, you need a case number, so please be in contact with our support department. They will give you a case number. Now, getting support from us is as easy as clicking to add a diag bundle, putting in the case number, and that will upload the diagnostic information to us for getting help from us. Additionally, also in our monitoring tab here, exploring our internal logs is now significantly easier. So I can see all the different worker nodes that are here. I can navigate into a particular worker process. I can see exactly what their logs are in a well-structured interface. We have some easy to use drill down type of capabilities. So I can add, that type of drill down, rerun my search. Now I'll only see info level messages. So this is the first cut of our internal log search feature. It'll be improving over time. Right now I have to select each individual worker process. We'll make that better over time, but you can see kind of how we're going and what we're doing to try to make it easy for an administrator to be able to troubleshoot, their running pipeline. So also wanted to show one other thing, which is that we also have a number of new sources and destinations, and we've now, from the sources and destinations, we now provide a more browsable, easy to use at a glance view of what we have here and configured. We've added support for HTTP event collector raw. We've added support for a new TCP input that's just raw TCP. So these are constantly ever expanding, and we're trying to make it easier for you to see kind of at a glance what we support and what will work with Cribble LogStream. So with that in mind, let's go ahead and start to wrap up and move into Q&A. So one thing I want to note is please check out sandbox.cribble.io. We have launched a beautiful new landing experience here. And if you want to play with this new replay technology and data collection technology, it's just as simple as coming here and standing up your, entering your email address, and there's a 30-minute course which will walk you through in detail how to use the feature that I just demoed here in the webinar. So please go check out the sandbox. This also comes with a certification certificate at the end. So we highly encourage you to go learn about this new feature, how it may work for you, or if you're a partner for your potential prospects. And then lastly, if you have any questions, please do check out our community Slack. If you're not already on there, this is the best way to get a hold of Cribble teammates and resources. So just come to cribble.io/community, pop in your email address there, join our Slack. We'd love to talk to you. If you have any questions, we can answer them there. And now, for the purposes of the webinar, let's go look at Q&A.
So we have a bunch of questions coming in. I will remind everyone that there's easiest way to ask a question is to use the Q&A button at the bottom of your webinar console. And with that, I'll start queuing up some of the questions. So somewhat early on, I think when you're going through some of the new features, we had a question: any plans to add dedupe and log reduction features for popular log sources, for example, Active Directory, moving description data and logs?
Yeah, so I think there's two questions there. One is, can I do deduplication? Yes, you can. That there are suppression features in the product today. And then the second question is, are you planning to add content around that? We have some content already built into the product. So if you look at, if you go into a worker group and you look at pipelines, we have things for like Windows event logs, Palo Alto logs that have some basic opinions about what you should do with that data. But content is definitely on our roadmap. This is something that we're working quite actively on, and you'll see us continue to invest in our, if you go to github.com/cribble.io/cribble-content, there's some stuff out there. And we're going to be working to enhance that, and it's definitely on the roadmap for this year. So some content, not as much as we'd like, more coming later.
Right, here's another one. Can data collection be encrypted before you store it in S3?
There's two kind of levels to that question. Like one is, can data be encrypted at rest in S3? Well, Amazon offers that that feature set. So, if you're talking about just full bucket encryption and encrypting of the contents and making sure that only the right systems have access to be able to get to clear text, S3 offers that, kind of out of the box. If you want to encrypt some portion of the payload or potentially all of the payload, we offer an encryption feature for that as well. So we lay the data down and we read it back, so you can encrypt and decrypt with native features of Cribble LogStream that we've had since version 1.3 that we talked about in the history.
So kind of along that line, I see references to AWS API secret key. Is this a had dependency, or can I assume an IAM role instead?
Yeah, so I talked about that during the demo. You can use an IAM role and showcase that during the demo. I think that came before I actually did the demo. So
fair enough. Let's see what else. Okay, so I think so. Does the feature that was just presented mean we can pull logs from AWS S3 bucket as needed? And is it pulling into Splunk or into Cribble itself?
So the data comes through us. So when we're sucking the data back out, what you would have seen in the demo is that we're sucking the data back to the front of the stream, just like it was a streaming source. So we're running a batch job that's collecting data and streaming it through LogStream, which can then be delivered to any destination that we now support. And so given our routing capabilities, the canonical use case looks very much like this diagram, which is, you're going to have data coming through here. We're going to route some of that data to an S3 bucket, and you're going to be able to use the collector to bring it back to the front of the stream and deliver it to wherever you want to send it.
Here's another one. Hi, Clint. Can the collector feature pull data from an NFS or a Windows share?
Yes, we can pull data from any file, right? So showed that in the demo as well. You can have you can pull from S3, you can pull from a file system. So we support object stores or S3 compatible object stores, file systems, and scripts today.
Okay, here's another one. Hey, Clint, maybe I missed it earlier. With the idea of data collection being self-service, is there now an RBAC structure available to help keep users within their responsibilities?
Not today, but coming. Probably, this year. Probably, obviously we're already into the second half of the year, so that tells you the timeline when we expect it.
And it looks like there's another question. It's almost the same question. Any plans for allowing integration to specific Kinesis shard IDs rather than the generic endpoint?
That's a little lower level than I probably have. Maybe hit us up in the community Slack and let's have a more detailed discussion.
Can you see logs in detail? Sorry, can you see in the logs in detail what changes users have made?
Can you see in the logs in detail? No, but that's why we have the Git integration. I'm assuming you're meaning changes that users have made to our configurations. I'm not. If you're trying to see what changes LogStream have made, that's to the original data, that's a different question. But if you're just merely talking about, hey, like what changes did people make inside of this configuration, as I make changes here, we have kind of a GitOps like workflow. So as I'm running this job right here, for example, if I want to turn off this data collection job right now, data will end up going somewhere else. As I hit commit here, I'm showing you a detailed diff of what's changed in this particular, as I made this change. I'm going to say turning a collection route. And right now I'm logged in as admin because we're not integrated with any sort of external system. But if you're integrated with OpenID Connect or Active Directory, it'll show your proper username. So I can actually see a diff here of what I actually changed. And actually, as of 2.2, I can even revert that, although I'm not reverting to the right commit. I actually need to revert to the commit before that. So I can actually come here and go, hey, I want to revert back to this commit. Okay, cool. And that change that I made after this revert happens, that route will come back on. So we can see now we're back to where we were.
Cool. Has the use of data replay feature been documented with its particulars in the Cribble blog? There are a couple of new articles on the blog, one announcing 2.2 that goes into data collection, and another one called Data Collection is Here by our head evangelist, Steve Littress. And there'll be a couple other data collection specific blog articles coming out in the next week or so. So please check the blog. There will be A lot of information there, and I think there's a lot of the technical detail in the release documentation as well.
Yep, and also check out the sandbox. So if you're really looking for a how-to or understanding use cases, the online sandbox for collection is the place to go.
Right. For centralizing all patterns, it'd be good to have an integration with GitHub for effective version control. Any plans?
Yep, just demoed that. Already there. So also you can push though you can push that out to GitHub. So you can define an external remote URL and potentially a private key if that's how you do authentication. And that can all these configs can be pushed up to GitHub.
Do you get double charged on replay in terms of licensing? So if I ingest 1 terabyte and route it to S3, then replay that data and want to send it to Splunk the same day, would it cost me 1 terabyte of license or 2?
Yeah, I mean, it would cost you 2. I mean, and this will change, like for ad hoc stuff, you know, this is sort of a benefit of the platform. You know, thinking about licensing will definitely come more into scheduled data collection where people are streaming stuff kind of all through. When we're talking about licensing with all customers, it's generally about understanding you know, what your normal day is going to look like. So if you've got bursty things like that, we're really just trying to get to a price point that adds the most value and that we can justify the ROI on. So you know, it's a little hand wavy, but we're not particularly concerned about hitting the max. So if you run like a job one day and you move 100 terabytes, but most days you move 2, then I'm concerned that you move 2 most days. That's kind of how we do licensing.
How's the data stored in S3 bucket local storage? What's the format?
Cool. Yeah. So it's gzip compressed new line delimited JSON files. So there's a JSON line per row. And then we can optionally compress that data. Generally, I think it's on by default. There's also the ability to just store raw log lines as well. So that's another option.
If data scrubbing is needed either direction, is that something Cribble provides as part of the tool, or would we need to bring our own processes?
Nope, like redaction and encryption, et cetera, is a core feature set of the product. So we make it very easy to go work with potentially, you know, any type of data. So as I pull up my sensitive data example, I've got a bunch of different kind of key value pairs. We make it easy for you to build using our mask function, the ability to mask or redact or encrypt potentially sensitive information. So you can see here we're matching this regular expression and we're replacing this particular, you know, sensitive social security number with an MD5 hash. We could also encrypt that data, et cetera. So being able to redact sensitive information is a core value proposition of the product.
Any plans for alerting integrations like Slack or PagerDuty?
Yes, maybe this year, maybe next. Not the next 3 months, probably not the next 6 months, but coming.
All right, I think we already covered it. Is data suppressed prior to writing to S3? Was that done from when pulling?
Yeah, so is data suppressed prior to writing to S3? I mean, you can. Generally, I mean, our advice would be put everything in S3 because back to the slides, penny on the dollar. You know, now that data is available to you in case you need it, and you can go pick and choose which of that data you actually care about.
All right, you support data collection by script. Does this mean that I could make, say, a bash script that is just a curl command and Cribble would take std out console write Cribble out? Can you see that question?
Yeah, exactly. Yeah,
Right.
yeah. The answer is yes. You can run any arbitrary script and we will take the output of that script and bring it to the front of the pipeline. So easily expandable.
So I think we've gotten through all the questions. Any other questions before we wrap up today? Great. Well, thank you everyone for attending. As I mentioned earlier, we are recording this and I encourage everyone to check the email that you used to register for the event, and we will send you a link to the recorded session. Thank you so much for attending and have a great rest of your day.